Hello, Ryan. Are you alright?
Yeah.
Okay, so
And that's
hello. Hello, Kitty.
Kitty.
Okay, so today we're going to talk about interesting problem called the number of bricks.
Brick layout.
Bricks layout. Okay. So what does it mean? So given the bricks of the size, like look, if this is 2 and this is 3, okay? The size, the width. Okay, set of width. And we have we want to place the bricks, okay, in width, and then there will be
A row.
rows. The height, okay, let's call it height. The height, okay. So for example, like 4, and each one is the same because we consider the height of the bricks is 1, right? So that will be 1, 2, maybe okay. 1, 2, 3, 4, 5, 6. Height equals 6. Okay. So the width is 5. How many ways of placing it? We can only place the bricks horizontally, one by one. Okay. So consider only one row. 5. You can choose the size of 2 and 3. How many ways of to place in bricks in a size 5? How many ways of doing that? 5. If I tell you, you can pick 2 and pick 3 as many times as you want. We have 2 types of bricks. So 5. We want to reach how many ways of putting the bricks
There's
in the...
6 ways. 5, 5, 5, 5, 5, 5.
Why is it? No. So 5, I have 2 and 3. I want to place the 2 in here. How many ways of placing the bricks 2 and 3
1,
into?
2, 3, 4.
No. Just considering this. Do you get it? How many ways?
2.
2. What are those?
2, 3, and 3, 2.
We're down. 2 plus 3 or 3 plus 2. Okay, so if this is 5, and there are how many rows, how many heights, how many rows? 1, 2, 3, 4, 5, 6. So each row has 2 possibilities. And how many ways of placing all of it? So to solve this problem, okay, so I give you an example. So look, this is a
12.
12? Why is it 12? Come on. Why is it 12? To B, to C. If there are 2 ways from A to B, 2 ways of B to C, how many ways of A to C?
6. No, 4.
4. Okay. And if there are 3 ways of A to B and 2 ways of B to C, how many ways?
6.
Yeah. So it times together. Another one. 2 ways of C to B. 2 ways of A to B, 2 ways of B to C, 2 ways of C to D. How many ways from A to D?
8.
2 times 2 times 2, right down. And 2 ways of placing the first row, 2 ways of placing the second row, 2 ways of placing third row, how many ways of doing that? There are 6 twos. How many ways?
12.
Why is it 12? You are good at here. Why is it 12? 2 ways of A to B, 2 ways of B to C, 2 ways C to D, and 2 ways of D to E, and F. How many ways of A to F? How many ways of A to F? You can give me, you don't need to give me the actual answer, but 2,
16. 32.
32? 2 times 2, 4. 4 times 4, 16. 16 times 2, 32. 64, okay? So the thing is that you multiply, you're not adding it together. You're not saying, oh, 6, 2, and then 12. It's the same, okay? A to B, 2 ways. Look, Eric, Ryan, A to B, C, D, E, F, okay? A to B, 2. B to C, 2. Got it? Yeah? Because each row has 2 possibilities. And how many ways of placing all these 6 rows to fulfill the wall with the 2 bricks? Yeah? 2 to the power of 6. Okay? Okay? Got it? Okay, so how can we do this? If we given a bricks is the size of the bricks, okay? Let's say bricks, which is a list of 2 and 3. And now we want the height. Height, let's say height equals what? 4, okay? And then we have a list width. Width equals 5, and then you need to tell me is what? Is 2 to the power of 4, okay? Because we can use 2 and 3, bricks of size of 2 and 3, to complete, to fulfill the wall, one row of wall with size 5. It's 2 plus 3 or 3 plus 2. And they are, if the wall has 4 meters height, right? So that's 2 to the power of 4. Got it?
Yeah.
So remember, we have talked about this. This is actually, let's consider, because if we consider this Fn, okay? If we consider Fn is the number of ways to place the bricks of this type in a single wall, and the answer would be Fn what? To the power of what? To the power of what? So actually Fn and Fn is Fv. The answer will be Fv to the power of height, right? Double height to the power of height. Okay, so that's the answer. So we know this height is to be calculated this way. So we just want to calculate this function f width. Yeah, we just need to focus on this f width. Okay. So how can we do this f width? So we can rephrase this problem as given a number n and given some numbers to pick. Okay, some numbers to pick. I is the numbers to pick from the bricks. Okay. This symbol, okay, this symbol. Look, Ryan, this symbol belongs. Don't touch your body. You just touch the cat, okay? Belongs to bricks, okay. So what? Fn will be the sum.
It looks like a C eating the minus sign.
Yeah. Fn will be the sum of what? The sum. Remember we talked about the sum. This one, sum. This is the sum of Fn minus I, right? Where I belongs to the bricks, okay, and n bigger or equal I, okay. So this is the function we want to calculate it, right? So what are we calling that? Look, we want to calculate Fn function, and we need to calculate Fn minus I, where I belongs to bricks. What is this argument called? Remember? What does this called? What does this called? Remember, we want to calculate this function, but in order to calculate this function, we want to calculate these sub-function with the smaller values. So how can we solve this problem? Using this. What kind of function are we talking about? Recursion, yeah. And we can memorize this. Yeah. What does that call? If we memorize this. Memoization. What do we call it?
Top down and bottom up.
Yeah, top down dynamic programming. Okay. Okay. So let's talk about the top down. Okay. And you tell me what to write. Okay. Define Fn. Fn. Okay. Maybe we write it. Let's say the bricks. With the bricks we have
Got something. Cash.
Not yet. Bricks. We want to have this brick. Okay. So.
Define.
Define what we call it. Let's call it as the count. Okay. Just count. Count how many ways of it. We want to have these bricks, the input, and the width and the height. Okay, width is the width of the wall. Height is the height of wall, right? Okay, so now we want to define this f function. F function which is n, given the n, right? Look, if n is smaller than 0, return what? If the width is smaller than 0, return what? If the width is smaller than 0, return what? Return what? Right? If n is smaller than 0, what happens? Return what?
If n.
How many ways to?
0.
Yeah, return 0. Yeah, return 0. So return 0. And if n is 1. If 0, then we return 1, right? Okay. This is determinate cases. Then answer equals 0. We want to sum up. For I in bricks, right? Now what we need to do? Answer plus
equals F
F.
N minus I.
Yeah, F n minus I. Okay, because look, let's
Return
always look. Fn we just say is the sum of Fn minus I, where I is belongs to bricks. Okay, yeah, okay, and n needs to be bigger or equal than I, but that's okay. We don't check here because if n is smaller than 0, we just return 0 here. Yeah, return answer. Okay, return answer. And what's missing here?
Cash.
Yeah. If we're not putting the cash, what happens? What's the time complexity if we're not putting the cash? If we're putting the cash, what's the time complexity?
I win.
No.
Log N.
No.
I won.
No, don't guess. Look, what's this? Oh, this is if there are n bricks, okay? So this is On, but we're calling it, right? So that will be V. So this is On times.
Width.
We are calling. Look, return.
Times N.
Return f what? F width, yeah? Width times this is to the power of h, right? Yeah? Look, this is to the power of h. So fw, this is called for each case for each fw value, right? We only calculating once, but for each f we need to sum up with bricks, so it's actually On times w, right? Got it? Yeah? Does it make sense? Right. So if we don't put the cash value, what happens?
Explanation.
It's exponential because these values, some values are calculating over and over again, right? Okay, I can give you an example. Yeah. So let's say f 100, and then if the bricks is 2 and 5, okay, right? So you will calculate. You will need to calculate f 98 and then f 95, right? Right? And then that will be f 96 and f 90. Okay, let's write another way. F2 and F1, okay? F99 and F98, and F96 and F97, and that will be F98 and F1 97. You see? Look, this F98 calculating here and here. F97 here and here. And look, there will be lots of calculation under this F, right? If we are not caching this value, what happens? When we come here, we need to do it again, right? But if we remember, we already calculating here, we remember it. What we can do is what? We just look up the value in a notebook, right? In a hash table. That's what we will put it a cache, right? So that's why, because look, F100 is what? 100 is the W value. So we actually just need to calculate F0 to F1 to FW. For each F value, we only calculating once because we store it using cache, right? But for each F function, we need to go through the bricks. Go through the bricks, right? Go through the bricks. So let's the n. So n bricks. So for each one, so the complexity will be W times n, right? Okay, so this is called top-down dynamic programming, right? We're using the recursion with the minimization. Got it? Okay, so tomorrow we're going to talk about bottom-up, okay? So can you explain to me what's this? FW times H, what's this?
F width times
Times H, what's this? Do you still remember what's this mean? 2 times 3, what's the answer? What's this? To the power, right? 2 to the power 3 equals what? What's the 2 to the power 3? What's 2 to the power 3? Come on.
2.
Remember, this FW is one row, right? And then if there are three rows, what's the answer? If there are two ways of placing one row,
8.
Yeah, so what's b? 2 to the power 3 is a, right? It's 3 2 times together, okay? 3 2s times together, or you can write the power 2 3. It's the same thing, yeah? 2 to the power 3, or 2 times 3, okay? Got it?
Yeah.
Do you want to write it here? Answer what? Can you write here? What's this? You want to write it here? Come on. The key part, yeah, remember? Yeah. Come on, write.
Answer.
Yeah, answer what? We want to accumulate the answer, yeah? Answer what? Answer what? Come on, don't look. Answer what?
Plus equals Fn minus I.
You know it, right? Why you need to look at the answer, yeah? Answer equals what?
F.
F, yeah. F what? F what?
N.
Yeah. Bracket, yeah. Yeah, minus I, right? Because we're looping it. And this is the recursion calling itself, okay? Got it? Okay, that's it. That's it for today. Thank you.
Wait.